Okay, Ryan, can you answer this question? Wait a minute. Ray is going to answer this question since it looks like he's modeling for us today.
It's when you take a diagram and you put it on your head. And you still want to do it. Am I close?
Okay, so now you're gonna say what is modeling from experience. You've been on the runway. Okay, what is modeling? What is modeling? Okay, shh. I don't know about you guys, but the class has already started. I don't know where you guys are. Yes. It's taking pictures. Okay, let's ask the compact lady here because seems like she's practicing for being on the runway. What, in the compact? Yeah, really, it's a pencils and pens for your eyes? Yeah, sure. Okay, yeah, what is modeling? Isn't it just girls that do that? Guys do that too? Oh, really? Oh, just talking about modeling, just to let you know, one of my young students was in the Miss World pageant in England. Can you believe that, from Fremont? Victoria Pham. Victoria Pham was my student, I think, 4 years ago, 3 years ago.
Is she related to Mrs. Pham?
No, she's not. Good question, no. Oh, is that right?
You still have her number?
Oh, I didn't know that. Well, sorry, Miriam, to disappoint you, but not so. But not so. But not so. This is not modeling. You may think it is. You may think it is, but it's not. Yes. Shh. What? Today? Maybe, I don't know. Okay, so this clearly hasn't gotten your attention. So maybe, Ray, you need to come out here and do a runway thing. Kind of walk like, strut like a, what do you say? Strut like a who? Like a cat. Yeah, come on, Ray. Strut like a cat so that we can get attention. See how Vikram and Kylie have no idea what's going on? Let's see if you can get their attention. Hey, wait a minute, he doesn't pass. You still haven't gotten their attention, man. Ray, maybe, hey, Ray, you need to go down their aisle there. Go down their aisle, Ray, come on. Maybe you might get their attention. Yeah, exactly. No, down the aisle there, man.
Oh, I got it.
Okay, you guys. Okay, Vikram, I don't know what you're looking at, man. But the action's here, okay? Sona, chup kar. Udara, chup kar. Shut up. Yeah. Got it? Okay, can I move? Can I work? Okay, let's go. So it's not that. But what it is writing mathematical equations to things that happen in the real world. That's what modeling is, okay? So there are two models that I'm showing you here. One's called exponential growth and the other one's called exponential decay. Okay? So as you can see, there are equations that go with this, and let's see if I can kind of scroll this properly. There we go. So it's pretty evident that the red one is a decay. So that'd be this guy. Ah, should have used red for red, huh? So there's your decay model. Okay, that's this guy here. And your growth model is this guy here. And that's this guy here. Okay. The term's fairly obvious as to why one's growth and one's decay. Okay, in one case the function is increasing and growing. In the other case, it is decreasing towards 0. Notice that exponential functions never, although they may look it, okay, Vikram, come and sit here. Although they may look like they're crossing the x-axis, they never do. Okay, so exponential functions never cross the x-axis. Wait a minute, that's not quite true. That's not quite true. You could get a function, an exponential function, that's kind of shifted like that. So for example, if you had 3 to the x minus, let's say 5, then you know that your function 3 to the x that might be looking like this will have been actually moved down 5 units. So it'll actually go down like this. Okay, so it will cross the x-axis somewhat. Okay, so you've got to be careful with that. Okay, you've got to be careful with that. So everybody got the idea about growth and decay, right? Okay, so now this is a problem that's really from chemistry, and I want to tell you that you want to be serious about this. Because 98% of the time my students never understand this. Okay, they never understand it because they do a lot of BS business. Okay? So we'll try not to do BS business, okay? By the time you come back, we'll be done here. So it's your choice if you want to go. Okay, so you want to put this in your graphing calculator. Okay, so you get 10. Everybody know where E is, right? Okay, negative 2t, negative 2x. So instead of t, it's an x. Okay, everybody got that in the calculator? No, are you with me? Did you get it in? Okay, graph that. We need to change x min and x max. Okay, so go into window. X min is 0, x max is 2, y min is 0, y max is 10. So that's a better looking graph there. Okay, everybody got that down? Yeah. Udara, I will have to send you out now, okay? You are now on record for being out. I just can't understand it. I've been telling you since the beginning of the year. We are now at the end of the quarter. And I still haven't gotten your attention. All right? What I want you to do is I want you to find out what the y value is when t is 0. Find the y value when t is 0. Find the y value when t is 0. Eric, what do you get? 10. Okay? Then move your cursor to where along the graph to where the y value is less than is equal to 1/2 of 10. You guys with me? Do you know what I'm talking about? You guys are using trace, right? Sorry, do you have a question there? Okay, do you know what I'm trying to tell you to do? Move the cursor to... Can you guys wait until I finish? Can you guys move the cursor to where the y value is half of what you started out with? So you are right. Surbir, half of 10 is 5. You're right. So you're going to move the cursor until y is equal to 5. You can't go to the table because the table is not going to give you exactly 5, is it? Again, y value is 5, not x. You could, but I want to see it in pictures so you get a feel for what's going on here. You might not get exactly 5, but let's say you've got exactly 5. Let's pretend that that's exactly 5. Okay? All right, come on, you idiot. Okay, I'll have to. What's the? I'll have to live with this. Okay. So on this exponential decay graph, what's happening is that when you come to the halfway mark from the beginning, this point on the x-axis is called the half-life. It's called the half-life. Okay? Because it took like 0.3404 seconds, okay, for the stuff to go from 10 to 5. Okay? Half of what you started out with. Okay? You guys understand what half-life means? Have you guys done chemistry? Have you done half-life in chemistry?
Yeah.
You've done radioactivity? Right? Do you guys know what half-life means there? Yeah? Well, graphically now you can see what happens, right? So let's say you started out with 10 grams of radium. And you know radium is radioactive, right? So it's going to be giving out particles and it's going to decay. And so its mass... Elim, can you come and sit here in the front? Survey. So you know how the particles are going to be what's the word? Radiated. And its mass is going to decrease. Okay, when it gets to be half of what you started out with, the amount of time it takes to get there, it's called a half-life. Okay, everybody get that? So now mathematically we need to really figure this out, okay? Let's not worry about this. So let's do this problem here, okay? Because this is where the rubber meets the road, okay? So this is a very classic radioactive problem. Classic decay problem. To us, okay? What's happening to this guy? We're going to use this basic decay equation. Okay? Notice that in this case, this is called a decay constant. And it's the Greek letter alpha. And the way that we've got the equation written, this is always going to be positive the way we've got it written. Okay? And Q0 is the initial amount. Okay? So first of all, what we've got to do is we've got to figure out what to do with this 16, 20 years. Okay? And t is in time. So let's say you started out with 100 grams of it, okay, of radium. Okay, what's the amount of half-life? Was 50. So Q is going to be 50. Q0 is 100. E is your favorite E. Everybody know your E. Alpha is alpha. Do I know what T is? Sorry? Yes. Exactly. Who's that? Yeah, what is it? 1620. Because that's how long it takes for the radium to go from 100 grams to 50 grams. Is everybody with me on this? So then this becomes 100 e to the minus 1620 alpha. Do you guys know how to solve for alpha?
Yeah.
What do you do?
The 100 to the...
Okay, and what do you get? Don't you get a half?
Yeah.
If you divide by 100, don't you get a half?